Good
Good evening, everyone. Today we are going to discuss solutions of April 23 paper, and I will start with the very easy questions. And if possible, you all can see the paper in your desktop at M Prakash Academy. Because last time what happened, when I took a lecture, the my video was very short, small screen, and paper which I shared on the screen became very big. So it should not be a case while recording. So in recorded message, it was a very small video of mine and a larger picture of the question paper. Today we are going to discuss this paper starting with the very easy ones and then go to the difficult ones. So today we are going to discuss question 30, which is a very easy question. And I hope everybody has seen those papers before the class as I had expected. I had told you all that before the class, please study the paper, then you will understand the theory behind it very easily and quickly. So today we are going to discuss question number 30. N is a natural number. It is given that n plus 1999 plus n plus 2000 etc. till n plus 2023 is a perfect square. I'm going to find the least value of n. Now I'm stopping the sharing of screen so I can be bigger. Here we are. So basically, if you subtract 2023 minus 1999.
Sir, can you increase the voice of your mic or something?
Full कर जाओ तो full full कर
नाही तो बॅकग्राऊंड नॉइज पिकअप करतो खूप.
हरकत
नाही आता बोला.
हाँ can you hear me?
Yes, sir. Yes, sir.
Okay. So instead of subtracting 1999, I am subtracting 1998 a number previous to that. So you don't have to add one. So this subtraction gives 25 numbers are there, and 25 numbers means 25 n's are involved plus the thing is starting from 1999 till 2023 upon 2. This is 25 terms. So 25n, and this 1999 plus 2023 is how much? 4022 upon 2 into 25. So this will be 2011. So you can see the 25 is a common thing. So we have n plus 2011. So basically n plus 2011 should be a perfect square because 25 is as it is perfect square. So I can see quickly that 40 square is 1600, 50 square is 2500, that is too far, and 45 square is 2025. So n plus 2011 should be 2025, very near to it. So basically 2025 minus 211 will give you the answer of the least number of n, which is 14. That was the solution. So you can copy it down. I'll wait. If you have any concern about this question, you can ask me. कभी एक पार्टी सुन रहा था
Sir, what have you written the end? N plus 2011.
So the whole thing should be a perfect square. So the perfect
Yes.
square which I can see is 45 square, 2025.
Hmm.
So n plus 2011 should be 2025. So I have subtracted 2025 and 2011. Then the n is 14 as expected.
So the closest square is 2025.
Yes, after 2011. This was very easy. I mean, from calculation point of view.
Yes. So this was question number
30,
19, right?
30, 30.
Okay.
So,
Yes.
how did you get the second step 25 and plus 1999 plus 2023 that step?
Basically, we have to count all the numbers from 1999 till 2023. So if you start counting, there are 25 numbers involved.
So but why 1999 and not 1998?
Huh?
Isn't
Yeah, I have taken the number before 1999.
oh, oh
Count the numbers. If you
okay.
subtract 23 minus 1999, you will get only 24 as the answer. Then you have to count the beginning. So whatever you say, numbers are 25.
Yeah. Sir, I have a doubt.
Yeah,
Sir, how did you get the division 1999 plus 2023 by 2? Like, how?
this is starting number. No, there is a rule in arithmetic progression. First number plus last number divided by 2 into number of terms.
Okay.
That is the arithmetic progression. Sum of numbers.
So then why you get 1998 while subtracting instead of 1999?
Okay, I'll show you a very simple example. I have five numbers. Can you see my finger? I am showing five fingers, right? I say the first number is 1 and the last number is 5. If I subtract 5 minus 1, I get answer as 4. Now fingers I am showing is 5. 5 numbers are involved. So instead of doing 5 minus 1, if I do 5 minus 0, I'll get 5 direct answer. Or else you can add 4 plus 1 as 5 fingers. That is the approach.
Yes, sir, got it.
Okay, all I have copied down. Can I go to the next question? Can I rub the board or anybody still writing?
Yes, sir, you can.
Yes. Thank you. Now we'll do question number 29. So let me share the screen for some time. This is question number 29. A, P, B are collinear. P is between A and B. C, Q, D are also collinear and Q is between C, D. Let alpha 1, oh, alpha, lambda 1 is AP upon PB and lambda 2 is CQ upon QD. Find lambda 1 times lambda 2. Okay, so let me draw the picture of this. Three, 7, 5, 9. Point P is in between. So for the first part, तुझा इंटरनेट बंद है ना माझं? Can you see me? Can you hear me?
Yes.
हो येत
No,
आहे
sir.
व्यवस्थित हो दिसतंय ऐकू येतं
Yes.
व्यवस्थित हो हो
So P is a point and the coordinate of P are 47, 11, 91, 11. So I am taking the x coordinate of P, 47 upon 11, and the x coordinate is given by the ratio m into 5, 5m plus 3n upon n plus 1, n plus n, sorry. So we solve this 47m plus 47n equal to 55n plus 33n. So it will be 8m equal to 14n. So m upon n will be equal to 14 upon 8, which is nothing but 7 upon 4. So that is first thing. Second thing, second line, CQD. C is minus 10, 1. And D is minus 1, minus 3. Let me call the ratio as A is to B. So the Q ka x coordinate is Qx coordinate minus 22 upon 13 is given by A into minus 1 and B into minus 10 upon A plus B. Solving this, minus 22A minus 22B equal to minus 13A and minus 130B. So 22A negative, I will transfer to the right. So 22 minus 13 is 9A, and transferring 130 to the left. 130 minus 122 is 108. 108B. So A equal to 12B. So A is to B is 12. So as you can see in the question, AP upon PB, they were asking. That was lambda 1. So AP upon PB is this one. And
Says not coming.
Can you hear me now?
Yes.
okay, so lambda 1 into lambda 2 is 7 upon 4 into 12, which is 21. Any doubt you can ask me, and if not, you can start copying the solution. Question 30, how can I repeat now?
Sir, from which paper we are taking the questions?
April 2023. The paper you can see on the website mprakasinstitute.com, because I have stopped sharing this session, the paper for full time. Last time video recording went like my window was very small and the paper was very big.
Sir, last time we didn't do one sum from the 2020 January
I
2023 paper.
Sir.
Huh? Yes, what happened? अरे बताओ भाई क्या हो गया? Section problem. So this was a
Sir, you are not.
Sir, you're not audible again.
yeah. Now can you hear me?
Yeah. Yes, sir, but very low.
Problem in the microphone. नाही बोल. अजून येतोय लो. फुल करना.
बाहेरच्या गाड्यांचा आवाज येतात.
किती गाड्या आहेत बाहेर.
खूप सेन्सिटिव्ह आहे. आता बघा.
हो. Can you hear me loud?
Yes, sir.
कुत्र्याचा आवाज येतो. Can I run the screen?
Yes, sir.
Okay. Let me share the paper again for some time. We are going to do question number 28. In triangle ABC, AB is 13, AC is 20, median AM is square root of 697 upon 2. Find area of A and B. So let us draw the picture. So I am stopping the question sharing. Okay. Question 28. ABC, AB 30 and AC is 20. So let me draw AB a little short, AC little long. So as per question, ABC 13 and 20 and median is drawn from A to M. Let's say like this. And the value of AM is given is square root of 697 upon 2. And we have to find the area of AMB, area of triangle AMB. Okay. So M is a median, so BM equal to MC. Now applying the Apollonius theorem here, AB square plus AC square, AB square plus AC square
Two
is
m
equal to
square is equal
2m square plus 2mc square. MC or BM, both are equal. Now we have some values here. AB square, 13 square, 169, 20 square, 400, 2 times AM square, which is square is 697 upon 4. So 4 will get cancelled out and 2mc square. So from here we can get the distance MC. So it is 569 and half of 697 will be 3, 4, 8.5. So 220.5 is the answer equal to 2mc square. So MC square is going to be divided by 2. So 110.25. And now, as per my shortcut theory, 10 into 11 is 110. So it is 10.5 square. So MC is going to be 10.5. So if you do 10.5 square, it will be 110.25. And since MC is 10.5, so BC is going to be 21. So this part was to find out the length BC. The next part is just doing the Heron's theorem. Semi-perimeter A plus B plus C, that is 13 plus 20 plus 21 upon 2, which is 41 plus 3. 44, 54 upon 2, 54 upon 2, which is 27. So as per the Heron's formula, the whole area of the triangle will be 27 times 27 minus 21, which is 6. 27 minus 27, sorry, 27 minus 20 is 7, and 27 minus 13 is 14. So I split up the things. So 27 I can write as 9 into 3, 6 as 2 into 3, 7 as 7, and 14 as 2 into 14. Now see, 9 can come out as 3, which is a, sorry. So 9 itself is a perfect square, so it will come out as 3. Then the 2 3s, I can take them down out as 3. Then 2 2s can come out as 2.
And two
Then 2
sevens.
7 can come out as 7. Huh?
2 sevens also, right, sir?
7?
2 sevens also will get cut off, no?
Yes,
Yeah.
sir. I've got these numbers out. 14 into 9. 14 into 9. How much is 120? No? 9. 120. 120. Sorry. 126.
126.
126. Now this is the area of the whole triangle. And you will see that bases are same. PM and MC have the same equal basis and their height is equally shared. So the area of, as per the question, A and B will be exactly half of the whole triangle area.
By
So,
BPT, right? Basic proportional.
area of the A and B will be exactly half of 126. 63.
Hello, sir.
Yes, sir.
Sir, why didn't you not use the half into base into height formula?
सर यहाँ पे height पता नहीं है ना. Base तो मिला, base equal to 21, but height we don't know.
Sir, can't we consider the median?
Pardon me?
Sir, can't we consider the median?
Median is not a height, it is not an altitude. You can see in my picture also that it is a AM is a slanting line looking in my figure, and height is the perpendicular from the top. So I'll show you the height. So this kind will be 90 degree will be the height. Let me call it as D point. So AD will be the height, but AD is not known. So we can't use half base into height.
Yes, sir.
That is why we have to use, because when you know sides, all the three sides, then the Heron's formula gives this area, rule of area, where height is not required.
Yes.
Sir, and where can we learn this Apollonius theorem? Like, where can we learn this? Are there sums given on it?
If possible, na, today we will discuss that Apollonius theorem, how to prove it at the end of the class.
Okay, sir.
Okay.
Sir, it is there in class 10 state board book, Maharashtra state board.
Really?
Yes. In triangles, I think Pythagoras theorem lesson. I think.
Okay.
Yes.
Because I have not studied all the textbooks of all the boards, so I am not able to explain me
Yes.
exactly which board it has.
There is explanation too in that.
Okay.
Yes.
Thank you for sharing the knowledge for everyone's benefit. Today 46, 43 children. So can I go to the next question? Can I rub the board or somebody still writing?
Yes, sir. We can.
Thank you. This was question 28. So we will proceed to question 27. Let me share the screen for some time of the question paper. 27. It's a function. Okay. F of x is ax plus b. And they want function of function x. Function of function x. 3f 1, 2, 3 is 27x plus 26. And they want answer of a plus b is how much? Okay. I stop sharing the question paper. Okay. Basically, whatever value you put as x will appear here in the part x involved. So if I say x is 1, then a into 1 plus b will happen. That is the function. If x is 2, then 2a plus b will happen. Like that. Now they want us to find out function x. Uska वापस function. That is what? Function. So this is the answer of the function x. So they want to find out answer of ax plus b. Taking that x as ax plus b and function of this is going to be a times, as you can see, a times whatever answer in the function will be multiplied ax plus b and plus b as given in the rule. So here x takes the value as the function value and a is the multiplicand and b is the constant. So this way you get a square x plus ab plus b is function of ax plus b. Now this is the first part. One more part. So we have to take a function of this again. So function of a square x plus ab plus will be a times function value a square x plus ab plus b plus the constant b. So this calculation leads to a cube x plus a square b plus ab plus b. And this value they have given in the question as 27x plus 26. So here this value is 27x plus 26. Now we will find the x term is only single term. So this should match to the 27x. And as a result, you can compare a cube with 27 and say very easily a must be 3. So from here we got the value of a. Now we have got the remaining function which is equal to 26. So definitely 26 will be the answer of a square. Now we have understood a is 3. So a square is 9b, ab is 3b and b. Now 12, 13b. So b is definitely 2. Therefore the answer required for a plus b will be 3 plus 2. 5.
Yeah, I don't understand what is the constant, the b.
B is a constant in the function.
Hmm.
A and B are constants. You can say A is a coefficient of X, B is a constant.
Okay.
Just note down things. I'll wait for a minute. Now we'll go to question 26. Let me share the screen for some time. Somebody still writing, or should I proceed to question 26?
Sir, 1 second.
Sir, can you wait for a second?
Okay, so
Done, sir.
done, everyone? Can I rub the board?
Yes, sir.
Okay. So this is question 26. So there's a circle and a square inside the circle. And the line is extended, and this is ABCD square. And then there is a tangent to C, which is equal to P. Wait, let me draw a little better, because there is a circle having center at O. Then you have to join PD. Okay. So ABCD is a square inscribed in a circle of radius 1. So radius is 1. The tangent to the circle at C meets at AB produces to P. Find PD square. So the question is demanding, what is the value of PD square? So I'll stop sharing the question. And this is the given figure. You can think for a minute. No problem. I'll label the diagram. Let me call square is side of square is x.
Sir, first we can find out the side of the square.
How, sir?
As given radius is 1 unit, so diagonal will be 2 unit, and we know that
Sir?
diagonal of square is equal to
So,
side.
yes,
Like,
I do the same thing what you explained. So in the triangle ABC, which is a 90-degree triangle, and radius is 1, so AC will be 2, point number 1, because radius is 1. Now we can express AC as AC square, which is diagonal, which is like a hypotenuse, equal to AB square plus BC square. So x square plus x square. AC square, which will be 4, equal to 2x square. So x square value will be 2, and x will be square root 2. But we'll see what is required in the question first. Now coming back to the diagram, the question is very easy actually. It's not complicated. As you know, diagonal in a square is always at 45 degree, because they divide the every angle in two equal parts. So even this is going to be 45, and you can see here 90 here, and this is a tangent which is again at 90 degree. Therefore, the remaining angle is going to be 45, and as a result, this angle P is going to be 45. And as you can see, the angle 45 and 45 and 90, that makes a triangle APC isosceles triangle. Looking at the isosceles triangle, looking at the angles, base angles are 45, 45 each. So AC is equal to CP in short. Now again, that makes it that AB, sorry, wait. So AC, so AB is also equal to BP by that theorem. Yes.
Sir, in triangle CBP, can't we use the Pythagoras theorem?
CPP. We don't have the information of BP and CP. How to use Pythagoras theorem?
Sir, we know that AC is 2, so CP will be also 2. And
That is true after doing this, not before that. So basically, what I am expressing here is that the two triangles, the short ones, I have not written on the board. Let me write it. Triangle ABC is congruent to triangle PBC by side, common side, and 90 and hypotenuse are equal because they are isosceles triangles. So RHS test. By RHS test, this statement becomes true. AB equal to BP. So the BP becomes X. And now you can see in the triangle APD, applying Pythagoras theorem. So PD square, which is a hypotenuse, is equal to AD square, which is X square, plus AP square, which is 2x square, which is 4x square. Total is 5x square. Now we have the already we have found the value of x square is 2. So 5 to the 10 is the answer.
So can you repeat this part again?
This one APD is a
Why have you taken
plus
4? Oh, got it, sir. Sorry.
in triangle APD, applying Pythagoras theorem, we get this result. So looking at the question, it becomes feels like very difficult, but it's not. So we have used twice Pythagoras theorem and once congruence test RHS. Please copy it down. I'll wait for a minute. So today our speed is very fast. We have finished 5 questions in just to say 45 minutes. Now let me decide which question to do. Question 25 is very tough, so I skip it for the time being. 24, we go to 24. So let me, have you written down or should I wait?
So we've written down.
Done, na? So I'll share the screen of the question for some time. So as I said, question 25 stuff. So I'm doing that question 25 later on. So first, let us finish simpler questions. So question 24 is simpler. Let me rub the board. Till that time, you can see the question.
Sir, can you wait for a...
Okay, tell me once done. Okay, somebody's still copying, so I'm stopping the questions here.
Yes.
Okay, again coming back to the question. So this is question 24. So let me rub the board. You can read the question, try to understand what information is given. Those who have tried this question paper before the class, as I was asking you all to do, that will be very good, because then solution becomes very fast to understand. Okay, so there are 4 unequal positive integers a, b, c and n such that n equal to 5a plus 3b plus 5c.
So can you use that mod thing here?
Pardon me? No, wait. Let us first understand question. And it is also true that n is equal to 4a plus 5b plus 4c. So I can write this expression is also equal to 4a plus 5b plus 4c.
So can you stop sharing the screen? You can see your board then.
Okay. Okay. So these two expressions can be made equal, because n is sharing this value, result of this as well as result of this. And the question is demanding what is a plus b plus c. So as per the given expressions, I can simplify as a plus a plus c is equal to 2b, bringing a 3b on the right and subtracting 4 and 4c from the left. So this is the result we get. A plus c is equal to 2b. Now if I modify this first expression as 5a plus 5c, bringing them together, 5a plus 5c plus 3b is equal to n, is the first equation. So I am bringing together 5a plus 5c. So I get 5 bracket a plus c plus 3b. And I can replace a plus c as 2b from here. Equation 1 gives a plus c value as 2b. So this is 10b plus 3b, 13b is a n. And in the question, it is given that n is between 131 and 150. N is bigger than 131, but less than 150. So in the table of 13, so 13's multiple is 143. That can happen n. So B will be 11 as per this given information, because n has to be multiple of 13, because this expression tells us that n has to be multiple of 13. And in the table of 13, n becomes 143, which is B is 11. And A plus C is 2B. So A plus C will be 2 times the 11, which is 22. And the final result required is A plus B plus C. So A plus C is 22 and B itself is 11 is the answer to the question 33. So many times we feel like questions are very tough, but solutions are surprisingly very easy. So please copy, I will wait for a minute. So should I share the screen for the next question?
So
Yes, sir.
Someone is still writing? Please tell me. So I am sharing the next question. Now, question 23 will do later on because that figure is tough to draw. But question 22 is little easy. It is based on arithmetic progression. So you can study that question. Meanwhile, I'll rub the board. For a given arithmetic series, the sum of the first 50 terms is 1275 and the sum of the next 148 terms is 6882. What is the first term of the series? Here there is a printing mistake on the website. That the word next should have been the first 148 terms. So that is little error, mistake while printing the question on the website. So, so first 50 terms, suppose A is the first term. So 50 A's are involved for 50 terms, and the last part will be, this AP I'll write on the top. It goes like this, if you are not aware of. Yeah.
stop the screen sharing.
Wait. Yes. That's what happened last class. So the arithmetic progression will happen like A is the first term, then common difference is D. So the terms will be A plus D, A plus 2D. So the last term is going to be 58th term. So 58th term will be A plus 49D. And sum of all this expression is there will be 50 A's involved and 1 D will be less because the first term does not have D. So it will be 49D is the, so we have to count 1 to 49. So 1 to 49 can be counted as this 49 into the next number 50 upon 2 D's. And the answer given in the question is 1275. So this is cancelled. So all the numbers are divisible by 25. So we divide by 25 and you get 2A plus 49B equal to 1275 divided by 25.
51. 51.
Correct. So this is expression number 1. Coming back to the next part as given in the question, the sum of the next knee, sum of the first 140 terms is 1682. So sum of 148 terms will involve 148 A's and you have to add 1 to 147 D's. So 1 to 147 D addition is 147 into the next number upon 2 D's and the answer is 6882. And this is 74. You can see 148 is a multiple of 74. I hope this is also multiple of 74. Let me
93, sir. 74 times 93, 682.
great. So with somebody's help, we realize quickly that this is a division. 93, right?
Yes, sir.
So this is expression number 2. And you have two expressions with two variables, simultaneous equation. So I can subtract equation 1 from equation 2. And when we subtract, 2A goes out of the picture. And this is 8D. This is 1598. And this becomes 242. So D is 42 upon 98.
So we can also substitute equation 1 in equation 2.
Yes, sir. That is also true. So choice is ours. Both divided by 2 gives 49. Divided by 7 gives 3 upon 7. So the common difference is 3 upon 7. And the question was given, what is the first term of the series? So you can use, let's say, equation 1 to get the value of A. So 2A, 49 times difference is we have found 3 upon 7 equal to 51. So 7 cancels 49 very nicely. So 2A plus 21 is 51. So that is 2A becomes 30 and A becomes 15 as required in the question. Now let me see how many are left over questions. 21, 23 and 25. Only 3 questions are left. It's not even 1 hour. What to do? काय विचारलं कोण? What is the formula used? Oh, arithmetic progression. Acha, if you want to understand what is this 49, 50, how did it come? So D's are starting from 1D, 2D's up to 49D's. So basically we are adding 1 plus 2 plus 3 dot 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 till 49. So this rule is given by the last number 49 into the next number 50 upon 2 is the sum of this 1 to 49 sum. This is what I used here.
Still, there's even that Sn equals sum of the arithmetic
Sum of
progression equals to
sum of number of terms, right? I hope that was a difficulty someone had in mind. And same thing, rule I have used here. So 1 to 47 addition is the last number 147 into the next number 148 upon 2. Sum of 1 to 147. So I'll wait for a minute. We have a lot of time. No problem today. So we are left with only 3 questions from this paper.
Can you tell once again how did you get 49 into 50 by 2?
49 into 50 by 2. See, I'll show you a very simple example, live example. Let's say I want to add 1, 2, 3, 4. Can you tell me mentally what is the addition? 1, 2, 3,
10.
10.
10. So because we had a limited number to add, we can easily add and say the answer. Let me use my rule. So the last number was 4 into the next number is 5 divided by 2. This answer is also 10. So we are using this shortcut to find the sum of the numbers from 1 to 49. So the last number here was 4 and the next was 5 divided by 2 was 10. Same theory I used here. Last number is 49, next number is 50 divided by 2 will be the sum. So sometimes it is very difficult to understand this, but when we take a live example like this, addition of 1, 2, 3, 4 is 10. Using the rule, we find answer is still 10. So we can apply this theory for bigger numbers involved. Okay, let me pick up now question for today. Out of the only 3 leftover questions. Let me see. 23. The diagram is complicated, but the solution is okay. 21. Lot of things to write. So 23 is the next question I would like to discuss right now. So have you all done writing the?
Yes, sir.
So I'm sharing the screen for question. What did I say? Question 23. Okay. So let me share. So share करो तो जो जी कैसे बनाऊंगी एक बार? Okay. First of all, I want you all to go through the question. A hexagon has consecutive angle measures of 90, 120, 150. Again 90, 120, 150. And if all of the sides are 4 units in length, we have to find the area of hexagon, which is given as k times 1 plus 1 upon root 3, and then find the value of k. So that is the question. So I'm stopping this screen sharing of the question. I hope everybody can see that question on mprakashinstitute.com's website. Oh. Oh. ती ईमेल कुठे टाकली? हे तर हे प्रशांत प्रशांत टाकतो समोर. कुठे टाकू? इथे इथे आणि सगळे बीएससी अलर्ट
नाही ठेवते लिंकचं फक्त लिंक ठेवतो.
सगळे बीएससी अलर्ट Okay, now let me share one. हे ओपन करते ना. Okay. Now let me share the sketch. This sketch was done using GeoGebra. Otherwise, it is very difficult to draw by hands and to understand the information like 90, 120, 150. So let me draw the same sketch on the board. You can observe the sketch. The angles are nicely going from A, B, C, D, E, F. Starting from AB, AB and B angle B is 90, C is 120, D is 150, again E is 90, F is 120, and the angle A becomes again 150. This for simplicity to understand how exactly the sketch should look like. Very difficult to draw. So I am making the same sketch on the board. You can also draw the sketch in your notebook. By the time I'll draw the sketch on my whiteboard. So all the sides are 4 units each. So I'm noting them. 1, 2, 3, 4, 5, 6. All are 4 units. So I have noted them. Now I'll stop sharing this picture and let's come back to the board. Let me call this point as A, B, C, D, E, F, G, and H. You can see the triangle CHD, where 4 is the hypotenuse as per Pythagoras theorem.
Sir, you have constructed the triangles on your own, right?
This one?
Yeah, as in HCD and AGF.
So I just noted that H is the point here. I extend this line.
Oh, you extended it, right? On your own, right?
BC and ED the H point. Now here, since this angle is 120, so you can imagine this, if this is 120, then this is going to be 60 and this is going to be 30. So as per 30, 60, 90 degree triangle theorem, 30 will be, a side opposite to 30 will be half of the hypotenuse. So CH will be 2 and side opposite to 60 will be root 3 upon 2 times the hypotenuse. So HD side is 2 root 3. And exactly what I am trying to do here is, we're trying to find the area here. Now let me shade it. This is the area question is demanding. And what I am trying to do here is, as you can see, as per this, so distance BH is going to be 6 side, and this is going to be 2 root 3 plus 4. So same will be down also 2 root 3 plus 4. So basically I am going to figure out what is the area of the rectangle here, and then I will subtract the areas of two small triangles to get the answer of the real area of hexagon. So I hope all have understood what 30, 60, 90 is. So the side opposite to 30 will be always half of the hypotenuse 4, the half is 2, so CH become 2. So you can see BC is already given as 4 plus 2, the total distance is 6. And side opposite to 60 will be root 3 upon 2 times the hypotenuse 4, and that value calculated is 2 root 3. So the total distance from H to E is 2 root 3 plus 4, which I have written in the bottom. And now we are going to find out the area of this rectangle. So area of the rectangle will be 6 times 2 root 3 plus 4, which is 12 root 3 plus 24. Now I'm going to find the area of the small triangle. Let's say area of triangle CDH will be half into base into height. Base is 2, height is 2 root 3. So the answer is 2 root 3. And you have two triangles of the same kind, up and bottom. So the area of the two triangles will be 4 root 3. So area of two triangles total is 4 root 3. Now I have to subtract this area of two triangles from the rectangle to get the area of the hexagon. So 12 root 3 plus 24 minus 4 root 3. So as you can see here, so 12 root 3 minus 4 root 3 will be 8 root 3 plus 24. So we found the area of hexagon. Now
So
the value,
the area of taken up what how have we taken that 6 into 2 root 3 plus 4?
6 into 2 root 3 plus 2. Area of rectangle. Can you see BG is the length and BH is the breadth of the rectangle. The big rectangle I am talking, BGEH.
Okay.
So I have found the area of the whole rectangle first of all, and then I am going to subtract the area of these two triangles, and the left over will be the answer of area of hexagon. That's what. So we found area of hexagon is 8 root 3 plus 24. Now if I look at the question, they say area of the hexagon is k times 1 plus 1 upon root 3. So let me write this information here. K times 1 plus 1 upon root 3 is the area of the hexagon, and our answer is 8 root 3 plus 24. Now somehow we have to match the requirement on the left hand side by doing some modification on the right hand side. So I can see here 8 is 0.1, 8 is a common thing. Then we are left with root 3 plus 3. Still it is not matching to the requirement of the bracket. So one bracket is 1 plus 1 upon root 3. So to achieve that, if I take out 3 common, 8 3s are 24 I do out. Now what happens inside? Here 1 will remain, but here what will happen? Root 3. I am taking 3 common and there is only root 3. So it will be 1 upon root 3 naturally.
Root 3 we have to take common.
No, I'm trying to match this bracket. So for which I have taken out 3 also. So from root 3 I took out 3. but there is only root 3. So root 3 into root 3 will become 3. So root 3 into root 3 upon root 3 has to happen. Then 3 will come out. Here, root 3 into root 3 upon root 3 is the root 3. So this gives 3 taken out, 1 upon 3 left inside the bracket. And then it is very easy to understand k is 24.
Hello, sir.
Yes.
Sir, what have you taken?
Say again. Can you repeat?
So we can just directly simplify.
Simplify what?
Sir, so we can simplify the bracket and then we can take out the top.
Whatever choice is yours. I prefer this method.
And
How
sir,
to take and get answer, that is your choice. Coming
sir,
to
how have
this,
you
coming to this step was very important. Point number 1.
sir, how have you taken out the 24? Isn't you've taken out the 3 there? Out up below the 8 ka step.
First
Below
I took
8.
8 out. First I took 8 out. When I take 8 out, this is the leftover information in the bracket. You agree?
Yes.
Now I have taken 3 out. Now there is no 3 here. There is a root 3. So how can I take 3 out? I have explained it here. Root 3 can be expressed as root 3 into root 3 upon root 3. So I don't change the value of the root 3.
Okay.
But here, when you multiply, you get 3 upon root 3. So I have taken 3 out. And then root 3 in the down will remain.
Sir, I have doubt.
Yeah?
In the question, it is given that all the sides are equal, that is 4. Means it is
Yes.
a regular hexagon. But regular hexagon have equal angles. So in the question, it is given different. So how that is?
This question is different.
Yes.
Basically, see, this question is not saying regular hexagon. The question is saying there is a hexagon where all sides are equal to 4.
Oh. But means such rare case can happen. Means like this in question.
I mean, see, it is there in front of you. It is
Okay.
not regular hexagon. It has different angles.
Yes. Okay. Okay.
And there is no word of regular hexagon mentioned anywhere in the question.
Okay, means so that side can be same and angles too can be different in some
Yes,
case.
it's the case in front of you.
Yes. Thank
And
you.
I have drawn this diagram using GeoGebra to explain you all.
Okay, thank you.
Sir,
Yes,
how are we supposed to do such kind of questions in the exam?
by practicing different type of various questions, you can go through the behind questions, past question paper, solutions are available. Every question is going to be different. I know that, but at least that's what, na? By at least discussing 2 papers, at least you will get some fair idea. Okay, these questions are not horrible. I mean, they are not out of the syllabus. But yes, they are very tricky, not very easy to crack, and that is the kind of interest is that is what is required. I mean, to say they can't give 10 cent questions, then everyone will pass. Then again, difficulty for selection. So can we use direct hexagon area formula and equate it? So that rule is for regular hexagon, and this is not regular.
Sir,
Yes.
yeah, so I have it out here. Instead of drawing the outer triangles and completing it as a rectangle, can we just join AC and DF there?
AC.
Yeah.
And
DF.
DF.
Basically, we divide the hexagon into parts, one parallelogram and two triangles, and then maybe we can find the area. Will that be helpful? Or no, it will be more complicated.
Let me see what you say. I make it ACDF. See the 2 triangles as per your division will give area 8, 8. And what will happen to this particular region, I'm crossing it. How to find this area will be a question. So you'll have to complete the figure, I don't know. But that can be another approach. No doubt about it. You can think as a homework, as a part of your work, further study of your own. But I've found this as a very quick approach to complete the rectangle and take out the area of the two equal triangles to get the area of that hexagon.
So,
But
when I
sir,
drew the diagram, the two diagonals didn't came into place. Like I drew it in a different way with 90 degrees as a top and like lantern type diagram. So then I thought of dividing it into 3 parts.
See, you try all your stuff as a part of a mocha. That's what I'm saying. At least I'm giving one solution. That is more important. You can have plentiful methods to do this question. I know. I'm not stopping you from doing it. So at least I should provide one solution. That is the intention here.
Yes, sir. Thank you.
So you can see, so you have one ready-made solution which is giving the answer of the question here. So you can try different ways of doing this question and see whether you are getting the same answer. If you are getting the same answer by the proper method, you are also correct. I don't deny. Okay, so I am going to share. I hope everybody has written by now. I am going to share the screen for the next question. गेली कुठे screen? मैं stop कर देता.
Hello, sir.
Yes.
So, in this method, in the other method, so we can get the side of AC and DE. We can find that out, and then we can just add those three. Because we can directly get the side AC and DE.
Sir, you can try everything as a homework. We don't have time for it. Discussing every method, possible method here. So let me go to the next question. Now I am sharing the screen for the next question, question 21. So you can study the question, and by that time, I'll draw the diagram on the board. I'll rub the board now. And I want you all to copy this diagram in your notebook because I'm going to do some marking. So we'll require, so we can save the time for everyone. By the time I draw the diagram on my board, you also copy same diagram in your notebook. I know it is very difficult to draw by hand, but can't help it. Should come up to here roughly. Okay. Then second circle will start here and travel here, and third circle will start here and travel here. Okay. This is question 21. Okay, I'm reading the question. The diagram shows three touching semicircle with radius 1 inside an equilateral triangle which each semicircle also touches. Diameter of each semicircle lies on the sides of the triangle. What is the area of the square whose length of the side is same as that of the length of equilateral triangle? So I am stopping sharing the screen. Then you can see the board. I have drawn this sketch. Doesn't look very good, but somewhat requirement in the question. I have made some points. Let that equilateral triangle be ABC, and centers of the semicircles, let us call it as EFD. Then I have joined EF, as you can see in the sketch, and they are touching. Therefore, they will be at 90 degrees, and they will be radius is 1. So I can say 1 plus 1 EF is 2, because this is a radius. This is also radius.
Sir,
Yes.
why it is 90 degree?
So they are touching. The semicircles are touching. So this will be straight line at 90. That's what my conclusion is. As a part of homework, then study why it is 90. Right now, I'm not explaining more, but I can understand.
Sir, it will be 90 because both the centers are in straight line.
Right. Now I am dividing this figure into little more parts. So let me call this is a radius. Till this point it is 1. And let me call this distance, the small distance left over is x. Now you can see there is a big triangle with a 90-degree angle, and we don't know much of it, but we know something about it. So you can say in triangle EFB, which is a right angle triangle, we can use the Pythagoras theorem, and we can call it as EB square is equal to EF square, which is 2 square 4, plus BF square and as
Sir,
you
or
see
by
in the
tan theta also we can find.
pardon me,
By tan theta,
pardon
all
me,
angles are 60 degree.
all angles are 60. I know equilateral angle. You can do by 30, 60, 90. You are suggesting, right? So once someone is saying, sir, this is 60, this is
Yes,
90,
sir.
so we are going to be
Follow.
30. So side opposite to 30 is going to be half of this, something like that.
Yes, sir.
Yes, sir.
So from that, BF will be 1. No.
Half of
Oh,
EB.
so EB ka half, but we don't know EB right now. Still there is a problem.
Sir, I got its answer. Should I tell?
So 2 is the answer of root 3 upon
Sir,
2 of the
that tan
hypotenuse.
60 equals E by V.
So
Sir, we have
side
A
opposite to
and B,
60
so
will
we
be
can find by tan
2
60.
root 3 upon 2 times the hypotenuse, which is EB. So from here also you will get the answer of EB as 4 upon root 3. Now somebody suggested that please use 60, 30, 90 degree theorem to find EB. We found it. So side opposite to
So how have you used 30 90 theorem?
here 90, this is equivalent to angle 60, so we said angle has to be 30.
Okay.
And side opposite to 60, which is 2.
Your voice is very low. Can you repeat it?
The 60-degree opposite side is EF, which is 2, and 60 side is root 3 upon 2 times the hypotenuse. This is what I have written here in formula.
Can we apply cot 60?
What?
Can we apply
Your voice is not
cot
clear.
60?
It's breaking.
So can we do something by joining the centers of the three circles?
You can do
Sir,
one solution.
sir, we can join that all centers we get equilateral triangle, and then we can apply trigonometry and we get answer.
So your hats off to you all. You can do anything, whatever you want.
Yes.
So I am trying to do this question without trigonometry. See, let me repeat. In maths, particularly, every question has many solutions. Whatever theory you know, you can apply it for every question. I don't stop you. Okay, now let me complete little more information here. Now I introduce one more point here, which is point P, which will be at 90. And we have one more Pythagoras theorem in the triangle BFP. Now this PF is going to be 1 unit, as you can see. So in the triangle BFP, we have BF as the, what is it, hypotenuse, which is equal to PF square 1 plus PB square. And you will notice that this BF dimension length is going to be same as EA. So EA length is also nothing but BF length. Now why I am doing this? Because we want to know the length of this rectangle, side of the rectangle. Rectangle, triangle, equivalent triangle. So I am interested in knowing the answer of AB to complete this question basically. If I know AB, then I can find the area of the square whose length is equal to AB. So area of the square is going to be AB square. So the entire intention is to find out the one side of the triangle, sorry, not rectangle, triangle. So basically AB length we are trying to find out.
Can you repeat?
So now what is left out? EB we have found 4 upon root 3. Now we have to find EA, which is nothing but BF. So here BF is 1 plus PB square. Now,
Sir, why is EA equal to BF?
why is EA equal to BF?
Yes, sir.
If you look the diagram closely, they are the same things. Even here, CD.
Yes, sir, got it.
So now I want to find out EA, and EA is nothing but BF in this diagram. Otherwise, I would have done this picture over here also, but that is okay. Somewhere we have to do this picture and trying to find out the value of BF.
So that small triangle is also means B angle B will be 60 and angle F will be 30. Then applying trigonometry we can get now BF.
Yes, sir. So PB or BF is 90 hypotenuse. So hypotenuse.
Sir, we
So
can also solve it directly.
side opposite to 60 is 1, and that 1 is root 3 upon 2 times BF. So BF will be 2 upon root 3. Nice suggestion. So now we have the side EB, which is 4 upon root 3. So let me represent AB, the total length, as broken part is AE plus EB, which is AE. AE is nothing but BF. 2 upon root 3, and AB is 4 upon root 3. So this becomes 6 upon root 3. So that if I divide 6 by root 3, I should get 2 root 3 answer. And the side AB is 2 root 3. And the area of the square is going to be square of 2 root 3, which is 4 into 3, 12, squaring it. Nice solution. 2 times. As I was trying to do something else here, but somebody told me. So don't you do this. So somebody stopped me here. Then somebody also stopped me here. And twice there was a solution, 30, 60, 90. Good choice. Students.
But it, how did you get that 2 is equal to root 3 by 2 into EB?
So you should know this property in a 30, 60, 90 degree triangle. So I am writing this here. So let's say this is 30, 60. Let's say this is 30 and this is 90. This is the hypotenuse. So side opposite to 30 is half of the hypotenuse, and side opposite to 60 is root 3 upon 2 times the hypotenuse. This is the theory I have used as suggested by some students here as well as here. So in this case, 1 was the side opposite to 60, and side opposite to 60 is root 3 upon 2 times the hypotenuse. So root 3 upon 2 times the BF hypotenuse, and the answer is 1. Same thing here. So now we are left with only one more question of this paper.
So the answer will be 12.
Yes. Square of area of the square is AB square, and we found AB as 2 root 3. So square of 2 root 3, answer is 12. So just
Okay, sir.
quickly write down. I'll just come in a minute. Okay. Is anybody still writing? I'll wait. We have time. Time is not an issue for today. For people. Are you ready?
So now we only have
Say again.
now we only have question number 25 and that one question of last time, right?
Yes, only 2 are living, and both are tough. So in a paper, while solving, you don't go behind the tough ones. Then you will waste the entire time in doing those tough questions and realizing, oh, I am short of time. So at the end, I'll repeat the what small thing I had told you while doing the real exam. That 5-1-1-1-1 pattern, if you remember, because you have to crack 50% score to become selected There is no point getting 100% in physics, 100% in chemistry, and maths only 10. So out of 10 questions from each subject, you have to crack 555 at least. That is a requirement. And you are selected. Okay. Now coming to the most very difficult questions of this paper and the next paper. I am sharing the paper. This is one of the very difficult questions. Theory is same as 10 standard, but the question is very tough. Now the question is not showing any figure, so we have to draw our own figure.
Sir, excuse
Yes.
me, sir.
Yes.
Sir, I have solved this 25th question. But in exam, if we consider some things like if the given is not parallel lines, so can we I have considered so many things in this question and I have got an answer.
See, you can imagine, but you are not sure whether they are really parallel, whatever you are saying. You have to prove that they are parallel lines. Whatever you are saying, you have to prove it. You can't, now there is no figure given also. So you have to firstly draw your own figure. I'll show you my figure in my notebook. I have drawn very carefully, and the figure looks like this. If you can see.
Can you stop sharing?
Okay. Let me stop the question sharing. The figure which I have drawn in my notebook carefully looks like this. And now you can see here, DE is parallel to AB as per my sketch, but we can't assume. You have to prove that DE is parallel to AB. So I am going to draw the same sketch on the board. Will not be very good enough. May not look like what I have drawn in my notebook. Very carefully I have drawn using the compass and all the stuff. Wait a minute. Okay. Again, I share the question with all of you, and I will start doing the figure as I showed in my notebook. So I'm trying to copy the figure in my notebook as good as possible, because many times we don't draw a very nice picture and we are confused with looking at the picture itself, and the picture is done by us. So question, angle B is twice angle C. So I say ABC is a triangle. I call angle C as X, and as per the question, this angle is 2X. Now what I have done in my picture was this. What is the question? Angle bisector of A. So I have drawn angle bisector of A, which meets at D. So I call this angle A as YY, and this is an angle bisector. So small angles are Y each. Now I'm going to
Sir,
do
can
one
you
more.
stop screen sharing?
Yeah, sorry. Okay. AD is the angle bisector. So I call the angle A total as 2y, and B is double of x, but I have not written 2x here because I am going to do angle bisector for angle B also, and therefore I will call that angles are x small ones. I am made this as point E, and I'm going to join ED. So these two parts were construction. They were not given in the question that you should do angle bisector for B, then you should join ED. That is by practice only you will understand. That is why this question is very tough. Extremely tough, I think.
But sir, we can even solve it by keeping it 2x, right?
Say again.
Can we even solve it by keeping it 2x?
You can try.
Instead of angle bisector.
Without angle bisector, I could not get the solution. Point number one, let me tell you.
Okay.
It was not very easy for me also. I am not a very expert in maths. But by some methods, I understood and realized there has to be some construction done to complete the question's requirement. And the question requirement is, they are just talking about what is the angle A. That's the question. They are not asking anything, but with this much information, without drawing this DE and ED, can you complete the question? You can see 3x plus 2y is 180. I can see this fact. You all will agree. But what happens to the value of x and y? From where we get x and y? That's the whole problem. So simply look at the figure, you don't know what is x and y. But if you know the value of x and y, or even to say, if you know the value of x, then you can find the value of y and you can complete the question of angle A. Now, how to find value of x? That is also golden question. Big question.
So we can do that by BPT. I did that and I got answer.
What did you say? Basic
By
proportionality.
BPT. Yes,
Basic
yes. Yes, by that we can get. I did the same and got the answer at last.
How do you apply basic proportional theorem here?
Means that DA is parallel to BA.
Who is given this information, sir?
No,
Who has given
but,
this information? Nobody has told you ED is parallel to AB.
but it will be.
It will be. Can you prove it? ED is parallel to AB. Golden question.
Okay.
So that's the whole problem. See, like my diagram in my notebook was showing ED looks like parallel to AB. Now in this diagram, it does not look like E1 because it is a very rough sketch. So as per my this sketch drawn on the board, you will say, no, ED does not look like AB is parallel to ED. So going ahead. So this entire question is based on angle chasing concept. So if you look carefully in the triangle, let's say BAE and triangle CAB, are they similar? Point number one. Can you prove they are similar? So in triangle BAE, see the A letter is in the center in both the triangles. So it is like a common angle, you can see.
Yes, sir. They are similar by 8.
And let's look at BAE. So angle B, we are talking here is X. And CAB
Sorry, your voice is very low.
is also X. What? What? Okay. So you can see the angle C is X and angle B is also X in these two triangles. Therefore, by SS theorem, sorry, angle theorem, not SS. Angle test, the triangles are similar. So if I use headphones, it will be better. Maybe. Okay. So basically, in similar triangles, what happens then is BA upon CA is also equal to AE upon AB is also equal to BE, first and the last letter, upon CB, the first and the last letter. because the sides are in proportion in similar triangles. Also, I am going to apply angle bisector theorem. AD is the angle bisector. So what happens in the angle bisector theorem? So AD is the angle bisector. So applying the angle bisector theorem, the sides AB upon AC is also equal to BD upon DC. I am writing that AB upon AC is also equal to BD upon DC. ABAC.
So, sir, what theorem is this?
Angle bisector theorem.
Okay.
AD is the angle bisector in the triangle. Then this is a theorem, angle bisector theorem. So sides are also in that way, proportion. And you can look carefully. I have written BA and CA, which is nothing but AB and AC. So the entire information also equal to BD upon DC. So this entire information is equal to BD upon DC. Now, if you look at this part, so I will only take this part and this part because AB upon AC is equal. So that means AE upon AB is equal to BD upon DC. AE upon AB is equal to BD upon DC. Okay, I forgot to write one more information. DC is equal to AB is given in the question. Let me write that fact. DC equal to AB. Because at this stage it is going to be useful. So can you see DC is equal to AB? So they will get cancelled out and we have AE is exactly equal to BD. Something more information will be found. So AE is equal to BD. So by using similar triangles, by using angle bisector theorem, we reach this point that AE is equal to BD. So basically we are trying to prove that ED is going to be parallel to AB. So we are going towards that. Now this is a in center. When angle bisector are meeting at one point, it is called in center. Now what I am going to use here is about the in center part. So I am going to rub the right side board to show you the in center. What happens? Then we can draw in circle. With the in center, we can draw in circle. So I am drawing the same sketch, showing you only the information about in center. So these are the angle bisectors. Then we get a in center. Now this again sketch is horrible to explain. Let me draw a little sensible. Okay, so this is I. So when I want to draw in circle, basically from the angle bisectors, we drop a perpendicular. Let's say a point called Z. So IZ will be the radius for drawing the in circle. So same thing will happen here. X. So IX and IZ are the radii for drawing the in circle. Now I am going to use this. So basically from I, you drop a 90 here and you drop a 90 here. The heights are equal. That is the concept I am going to use. And also you can drop here, third side, but third side is not required in the question. So basically here what I am trying to say that I is a in center, therefore the height here, I am not drawing here, I have shown here. And height over here is going to be same. And you can see that in triangle IBD, BD is the base, and in the triangle AEI, AE is the base, and we have proved that base are equal. And here I am going to say, because of in center, the heights are going to be same. And as a result, I can say comfortably, area of triangle AYE is equal to area of triangle AIE and BID are equal. And the concept is clear. The bases are equal and the heights are also equal because of this in center. So in circle drawn with the in center will have equal radii. Therefore, these two triangles are equal in areas.
Sir,
Yes?
sir, I have a doubt.
Yes?
Sir, when you drew the in circle in the second figure, sir, it is also seen that ID and IE are also the radiuses.
ID and
Maybe the radiuses for the in circle.
ID cannot be radius. Come on. In this picture also you can see they are the slanting lines. The height will be vertical drop, which I have shown here nicely. Is it clear what you are saying?
Yes, sir.
So ID cannot be the radius. So if you have studied angle bisector and then how to draw in circle, then you will understand what I'm saying. Okay, going ahead. I'm going to shade one part of the region, this triangle. Reason being, with this shading, I'm going to complete this next statement. So area of triangle BED is equal to area of triangle ADE, or let me say DEA. Reason being, these are equal, and the addition of this, because this is a common triangle area, so this is what I have written. So circle plus shading is also equal to circle plus shading. That is what I am showing here. Now I will draw another picture of the same sketch. I am trying to explain that. So same sketch being copied on the right. And we are going to closely observe what happens in BED here and DA here. Can you see DA is the same base for both the triangles? The area of the triangle cannot change, even when I change the base. That is point number one. So if I say this area and this area, so this area and this area is equal, and both are sharing the same base, which I am darkening ED. So I can look at the two triangles in this fashion. So the basically area with D is same base and B is at different point, A is different point with same base, and A, B are giving the same areas as I have shown here. That means A and B are at equal distances because height from A to the base, let's say roughly like this, and let's say roughly like this. So heights are going to be equal, then only their areas are going to be equal. And areas we have already proved by this simple sketch diagram that the areas are equal. That means as per by changing the base from BD and AE, I change the base as DE. Then you can see that A must be at the same distance from DE line as B is. Then only areas are going to be equal. So this point I have drawn to show that means A and B are equidistant. From DE line. And when I say A and B are
Sir, can you
equidistant,
explain it one more time?
which part? This part?
Sir.
Which part you want to explain? This one?
Yes, sir. How that A and B are equidistant? Yes, sir.
Okay. So you have understood how I got the triangle's area equal here, this part?
Yes, sir. I have understood.
You have understood this, right? So on one side we are saying the areas are equal. Same sketch I have drawn here to explain. If the areas are equal and if ED is the same base for both the triangles, then their heights must be equal.
Yes, sir.
So if they are equal heights, that means A and B are at the same distance from the line DE, which is base. So I am writing that point here. A and B both are at equal distances from DE. And it completes that means AB is parallel to DE. So all the way down the line, the whole thing was to prove that AB is parallel to DE. इतना सब काम किया ना हमने यही दिखाने के लिए ED is equal ED is parallel to AB. And you can see this figure is nothing but, now let me rub this sketch because I need the board. So I draw the sketch of ABDE proper. ABD, ABDE. And I have proved that AB is parallel to DE or ED, whatever you want to say. And also during the things, we have proved that AE is equal to BD. So what kind of figure is this? This is an isosceles trapezium. So this is our final conclusion to get the answer of the question. So not only ED is parallel to AB, but even the sides on the sides are equal. We have proved here. So this is tick mark here, very big tick mark. Second tick mark here, this one, and that leads to the fact that this is true. And you know the fact in isosceles trapeziums, the angle A and angle B are equal. And here we angle A is 2y and angle B is 2x. They are equal. That means x is equal to y is proved. Now the last part was very clear. 3x plus 2y was 180. And x is y. You can say 5y is 180. So y turns out to be 36. And angle is double of y, which is 72. This is the difficulty level of this question, wherein two constructions are involved, which are very difficult to do or think of it during the test. Very difficult. And you can understand what all I have to do to prove that ABDE is an isosceles trapezium.
Sir,
Yes.
will you please
please explain why AB is parallel to DE?
Why AB is parallel to DE? I was explaining beforehand. D is the same base, and the area of EAD is equal to area of EBD with the equal bases. So they will have equal heights. So A will be at the equal height from the line D, and B will also be equal height. That was the previous case I was explaining.
Sir, could you explain how AE is equal to BB?
Equal to AB is not equal to
AE
D.
equal to BB. No,
AE,
AE is equal to B.
that was here. See, we use
Yes.
the proportionality theorem of similar triangles, and you can see here, I'll point out again, BA upon CA, double arrow. Here also, AB upon AC, that is the same thing, written opposite way. And so BA upon CA is equal to this single arrow, A upon AB. And double arrow is also equal to BD upon DC. So I took a help of this. So these things are equal. So AE upon AB equal to BD upon DC. I have written here on the top. And then in the question it was given AB is equal to DC. So they will cancel out. So as a net result, AE equal to BD. See in the question this is given AB equal to DC. You can see the question. Whew, I'm tired. And one more to go. Children have also problem. See, one question took so much time to explain. That is why I kept this question as a last question for the test. For my test, I can say that way. Now we have one more question left. Whew, that is also very big and complicated. So I am going to give you the solution on my website, on my group. I will explain you the entire base of the question.
Oh, you can take a break of 2 minutes if you want, all of you. If
Thank
you're
you, madam.
tired, take a
Even I
break
am.
of 2 minutes. पाणी
Thank
प्या,
you.
जरा फ्रेश व्हा आणि मग करा ना.
Yes, thank you.
Yeah.
Others can note down and let us take a break of 2-3 minutes. And I will explain the question 21 of the last paper. Sorry. I'm back. I'm a little fresh. So let's continue the last question. So I'm going to rub the board. So before I go to the questions solution, let me quickly repeat what I had said. And that note is there, but this note is not there in our group. The pattern is 5-1-1-1 you should follow. You will understand that every subject has 2-3 very difficult questions. So let us not look at those three, forget them. Still you can get score of 7 in each subject. So basically what I said is, for every subject you solve 5 questions of physics, chemistry 5, then go to math section 5. Now you don't know how they were, good, bad. But then again you start solving one of physics, one of chemistry, one of maths, and keep doing this till the end of the time of the exam. Wherever you can reach. Very difficult questions as I have circled here, you can ignore. That very too tough to understand even. Don't attempt them, forget them. You just try to attend the first 7 questions which you feel little better off. And basically what you need at the end of the result is you need 5 questions right in every subject. That is a target. No one is demanding all 3 subjects you have to score 100%. So this is like my kind of shortcut for doing this kind of exams. Okay, so let us do the question 21. Now let me share the question paper. Let me open the paper first. Jan 23. So now I'm going to share it. Share. So you can see the question. Again, I'll give 2 minutes for you to think how to do this kind of question. Then we will see what the solution is about. Now, by the time you are thinking, let me draw the question on my board. Also, I want you all to draw the figure in your notebook. We are going to do some marking on the diagram. So there is a equilateral triangle ABC of side something. M and N are midpoints of AB and AC. Triangle is inscribed in a circle. Ray MN meets the circle at P. Determine length of the segment NP. Okay. So let me draw the circle. First I start with circle, then draw the triangle, which is the equilateral triangle. Name the points of the figure A, B, C. Then M and N are midpoints. So I am extending the line behind also. They are the midpoints, they are equal in lengths. And this is MP. And let me call this side extended PM line meeting the circle at Q. Now here we are. So I'm stopping screen sharing of the question. And this is my sketch. And let me see, where is my question paper? Where did I keep it? Wait. Okay. I have found my question paper. Now I'm going to call this length as x. So that x is given is root 45 plus 3. Little more modification. This is like 3 root 5 plus 3. So further simplification, 3 common, root 5 plus 1 is each side. Now I am going to use one theorem. Theorem is this way. In a circle, there are two chords intersecting each other. Let me show the same points. A and C is one chord. Let's say here A and C. And the other chord, which is horizontal line, here I am not showing horizontal, but it is same thing. So when two chords are intersecting each other inside the circle, then the product of the chords AN into NC is equal to QN into NP. This is our circle chord intersection theorem. So we are going to use this here. So I rub the diagram. I explained you which theorem I was talking about. And here we are. AN into NC is equal to QN into NP. If you look at AN and NC, both are half of the full length x. So AN is x upon 2. NC is also x upon 2. Now what happens to QN and NP? QN, NP. We don't know much, but we know M and N are midpoints. That much only we know. So NP written as NP and QN can be modified as QM plus MN. So I modified the QN part by breaking into two parts. If you want, I can. Okay, now let me go to the next one.
Sir, over here, MN, you can take MN as half of BC, right?
Yes,
By
sir.
midpoint here.
Yes, sir. I am going to do that one. And that is the same thing what somebody was explaining. MN is half of the base because the lines are having midpoints. Then the side is half the baseline. That is what suggested by someone. Also, I am going to write here that length QM, which I am drawing here, is equal to NP. If you apply the same theorem here, then you will be really able to understand why QM is equal to NP. Because as per this theorem, if you apply the same way here, that QM into NP is also equal to NP into NQ. And if further simplify, you will come to a result which I have shown here. Because further modification will be MP can be broken into MN plus NP. So let me show you that also. And NP as it is, and I can break NQ as again Mn plus Qm. So if you further explain Qm times Mn plus Qm times Np is also equal to Np times Mn plus Np times Qm. So what we have, Qm into Mn, Qm into Np. See this one, Qm into Np is same thing here. Now see, then we are left with this equal to this, and Mn is the same thing, that means Qm equal to Np. So here, by doing this, I have proved that Qm is equal to Np, which I have replaced in our solution. So I applied the same theorem as here, again for the same line in a different way to prove that Qm equal to Np. Now here, coming back to the solution, so it is nothing but x square upon 4 is equal to Np square plus x upon 2 Np. So I am writing this information here, Np square plus x upon 2, x upon 2 Np minus x square upon 4 equal to 0, and this is nothing but quadratic equation, if you understand. And in the quadratic equation, so the Np is the unknown thing which we are trying to find, and the equation is written in the formula method, minus b plus or minus b square minus 4ac upon 2a. And when you solve this, you will get a very nice answer of Np as 3. So either I can put the solution on our group, or if you want, I can do it here also. How do we get Np equal to 3? I think that is the answer. Let me see. Yeah, Np should be 3. So do one thing. Just copy the board, because I need to rub the board to get this thing done. That is why this question is also very tough. Not that very tough like question 25, where you have to do 2 constructions and then lot of imaginations. Those imaginations need to be proved. So here, that way, that is solution is okay, not a big issue. But solving this
Sir,
yes.
can you dictate me that NP square thing, because I can't see it clearly? Mine.
Say again, I didn't understand. What did you say?
Can you explain to me how that NP square is equal to this thing?
NP square. Acha, here. Acha, I have opened the bracket. NP into NP is NP square, and NP into x upon 2 is x upon 2 NP. And then I transferred x square upon 4 on the right side, and I have written this quadratic equation, and now we are going to solve this quadratic equation to get our final answer. That's it.
Sir, can you just once explain the theorem?
Which theorem? This one?
No, the first you use that 2 chords. Qn into Np is equal to this. Yes, sir, that.
So when 2 chords are intersecting each other, the product of the chords is same. This is what I have written. An into Nc is 1 chord, is also equal to the product of Qn times Np. And same theorem again I have used on the same line. Qm times Mp is also equal to Np times Nq. Twice I use that theorem. And this theorem is there in every standards, I mean board. I know for sure. So I'll wait for 2 minutes. Please note down this because I have to.
NP.
Pardon me?
You have written NR instead of NP in that quadratic equation.
Do you hear? No, it is not R. It is a dash by my finger. So just look at it. The other questions will be completed in 1 hour, and now we are still waiting for completing the remaining 3-4 questions for the last 1.5 hour. So please note down because I am going to complete this question on the board. So I am not putting solution with our group, but I am giving my time. No problem.
So in the quadratic equation, a equal to 1, b is equal to x upon 2, and c is equal to x square upon 4. Right?
Yes, a equal to 1. He said correctly. B is x upon 2 and C is minus x square upon 4. Please make sure
Oh, right.
minus sign also comes at C.
Yes.
Those who have finished writing, they can try this. No problem. Go ahead before me. So here, as per our quadratic equation, I am writing the information about A, B, C. A is 1, B is x upon 2, and C is minus x square upon 4. And this is what we are going to fill up to get the answer. And at the end, we are going to replace that x as here 3 times root 5 plus 1 to get our answer. And I am going to wait for 2 minutes. Not only those who are still copying, I hope everybody has copied. I am giving time to solve this quadratic equation. How to reach answer 3? We know the answer is 3. And we know value of x is 3 times root 5 plus 1. Can you do it? You have done so many quadratic equations with this formula. So that should be very simple job. So I am started to rub the right side of the board. If that is okay, anybody still copying, tell me. I hope everybody is done.
No, sir, you can.
So I can rub the board?
Yes.
Okay. Let's see if I can complete this question in this much part of the board. So I have explained what are the values of A, B, and C. Now let's look at square root of b square minus 4ac. First we'll find out b square minus 4ac is how much. So b is x upon 2, square will be x square upon 4 minus 4 times a is 1 and c is minus x square upon 4. So as you can see here that 4 is getting cancelled and minus are multiplying to get positive. So here I'm getting x square upon 4 plus x square. So if I simplify fractions, I will get answer as 5x square upon 4 under root. So I can get out x upon 2 out of the square root sign and I live inside square root 5. So this was b square minus 4ac. Square root of b square minus 4ac gave this result. Now I am completing this formula. Minus b. B is x upon 2. So minus x upon 2 plus minus x upon 2 root 5, everything divided by 2a, and a is 1, so divided by 2. So that will give me, 4 plus minus, Let me rub it. So yeah, so 4 is a common thing in down, and we have minus x plus minus.
So why 4?
Like this both the fractions are divided by 2, so each will become 4 4. Simple maths. So this will become 4, this will also become 4. Like a simple rule is like a fraction divided by another fraction is nothing but the fraction is multiplied by reciprocal of the down fraction. So it's like, this is a fraction divided by another fraction 2 upon 1. So just imagine the CD is 2 upon 1. So it will become DC, and 2 will join hands with plus 2. Now let me clear, because I need still space to complete this quadratic equation. So I have landed up over here. So there can be two parts to the answer. One can be minus x plus x root 5 upon 4, and minus x root 5 upon 4, because there are two signs, plus or minus. And as you see,
Sir,
both
the
are minus.
positive root works.
Yeah, so both are
The
minus,
positive.
and our answer cannot be minus. Point number one. So this case is failed, definitely. Now here I am. So I take out x upon 4 as a common thing. I write root 5 plus positive sign first, negative sign later on. So since this is failed, so I have bold to write. Now we know the x is root 5. What did I write? 3 times root 5 plus 1 was x upon 4 into root 5 minus 1. When you multiply a plus b times a minus b, you will get a square minus b square. So 5 minus 1 is 4. And as a result, this 4 nicely cancels out, giving answer as 3 as required in the question. So you can note down, then we'll stop the class. So for doing questions on geometry also, you need to have knowledge of algebras, like simultaneous equation, solving quadratic equations. They become again part of the geometry solution sometimes, not always.
So NP is equal to 3, right, sir?
Yeah, NP equal to. Basically, here I have written NP. I have not copied that NP. This was b square minus 4ac. I was explaining b square minus 4ac. And here we started with the NP solution, which I forgot to mention. कौन? And that's it for the today's lecture. I don't have anything more to share. I already shared in the first class what we should do. I hope you try and do the things which I mentioned last class, and the schedule is also mentioned on our group. And once you have copied, you can leave the class. Then I can see the count going down on the participant list. So those who have finished can leave the class. If you have anything to ask
Sir,
me, you can ask.
if you have any doubts on the papers we solve, can we message on the group?
With these two papers?
No, like other papers you will solve, like you said, no, the Sunday ka thing.
सर उसका सॉल्यूशन भी है ना साइट पे, कुछ तो मेहनत करो आप.
I'm but then if we still don't understand.
No, sir. This class was only meant for discussing these 20 questions of maths, physics, and chemistry. Because every child will have one doubt out of 10 doubts. One child will have question one is a doubt. Second will say question two is a doubt. And there are so many question papers. You can say 100 questions are there, and each child will have one doubt. It is not possible for me to give guidance to 100 questions.
Okay, sir.
Because then
Sir,
it
can
would
I
be
ask
like,
ma'am something?
ma'am, you want to ask? She's there?
Chem.
No, ma'am has left the meeting.
Okay. Okay.
But what you wanted to ask? You can ask me.
Sir, in chemistry, that
Huh.
day I was doing the session, but I had a
Hmm.
lot of connectivity issues. So, okay, can I have like a recording of a session or something?
Okay, you send me a message separately on my mobile number. I'll share the link. No issue.
Thank you, sir. Thank
Those
you,
can
sir.
be done. Yes.
Thank you, sir.
Any other difficulty, doubt, you want to clarify something? Those who have done noting down the solution, they can leave the class. I am in the class for you all to write down the solution, and then all the best to the exam.
Thank you, sir.
Sir, I have a doubt about physics.
Physics. What doubt?
Sir, in the current question paper, the last question paper, there was a question about heat, but there were three objects in the question, and we had to find the equilibrium temperature or how to do questions when there are
So
three.
that was April 23 paper?
April, no, November 24.
November 24?
The latest.
But we don't have the paper, sir. They don't share. The institute is not sharing that paper. So I don't know, my physics sir don't know what the question was. So it is very difficult to share the solution of that paper because they don't allow us to share the solution.
Okay,
Because
I guess.
next paper can be of similar nature. And if we discuss the solutions of that paper, November 24, and if there is a similar question coming in the next paper, which we don't know, it can be. They can change the values. Maybe concept is same. So they are not sharing those questions. So we are not allowed to discuss also. Any other query from the remaining group? So now only 12 children are left to leave the class. So I'll be back in a minute.